So you can see me, right? Everybody, you can see me? Yes, that's good. So this is the isotope, meaning the same element. I'm just talking about the carbon. I'm not talking about oxygen. I'm not talking about nitrogen. I'm just talking about the carbon, right? And the carbon has 6 protons. 6 protons. So proton is a small number, so I write it the foot, right? You can write it ahead, but you can write it the foot. So this carbon also has a 6 proton, and this carbon has also 6 protons. Yeah. So 6 protons, 6 electrons. 6 protons, 6 electrons. 6 electrons. So 6 electrons. 6 protons equals to 6 electrons. This carbon has 6 protons, 6 electrons. This carbon has 6 protons, 6 electrons. This carbon also has 6 protons, 6 electrons. But this carbon has 6 neutrons. So this guy has 6 neutrons. So 6 neutron, 6 proton. So this has 12. So so the mass number is 12, right? So it has 6 proton. This is proton number. This is neutron number. So 6 plus 6, 12. This guy has a 6 proton. This is proton 6 here, and then it has 7 neutrons. So this has 13 mass number. This guy has 6 protons, 6 proton or 6 electron, and it has 8 neutrons. So it has 14 mass number. So this kind of the things are called the isotopes. So isotope is the same element. Same element means they have same number of proton and same number of electron, but they have different number of neutron. The neutron. So this is neutron. This one is neutron. This one is neutron. This one is proton. This one is proton. This one is proton. So same number of proton, different number of neutron, and these elements are the same element. Carbon, carbon, carbon. Yeah. So these are called isotope. Make sense? Good. So let's talk about another one. So in nature, if you go and collect the carbon, this is about 99.9%. So this is about 1%, and this is about 0.01%. Very, very tiny amount, this one. So these are called isotope. Isotope are the same element. They have the same number of proton, but different number of neutron. Yeah? So there is a homework problem for next week from here. So now let's talk about fluorine. So fluorine. So if you see something like this, fluorine 19. So if somebody writes like this, fluorine 19 or carbon 13, you can write carbon 13. You can write sodium 23, sodium 23. So if something is written like this means that this is a proton plus neutron. This is a proton plus neutron, 19. Proton plus neutron is 19. Make sense? And then if somebody writes sodium 23 like this is proton plus neutron, number is 23. If somebody writes carbon 13, it is like proton plus neutron. So that's that, yeah? So sometimes they write like this, or sometimes they may write like this. Fluorine, it's 9 and 19. So this one and this one is same. So 9 is atomic number, 19 is the mass number. If they write fluorine 19, this is also the mass number. Proton plus neutron. Make sense? So don't get confused. Either they write F19 like this or F19 like this. It's the same thing like this. Yeah? Good. So how many proton there in fluorine? 9 proton, 9 electron. How many neutron? So neutron is big number minus small number. 19 minus 9 is equals to 10 neutron. In this fluorine atom, there are 9 proton. This means 9 proton or 9 electron. And 19 is the mass number. So 19 minus 9 is equals to 10 is the neutron number. So this is the neutron number. Yeah. So whatever is the big number minus the smaller number gives the another number. Yeah. All right. So you can easily see in the periodic table. So what is the atomic number of sodium? So sodium. So what is the atomic number of sodium? Just go to the periodic table and look which box it is. So it is clearly written that this is the box number 11 there. Yeah. So if you see the periodic table, here they write 11, and this is the proton number. And they might write 23 here. So what is the neutron number? So this is the proton plus neutron. This is the proton, right? So this minus this gives the number of neutron. Make sense? Good. So same thing. So 23 minus 11 gives 2, 1, 12 neutrons there. So 11 proton, 11 electron is here, and 23 minus 11 is 12 neutron there. Good. So there are a couple of examples here. So let's talk about this example. Which is there are three particles. There are three subatomic particles, right? So inside the atom, there are three particles, three kinds of particles. One is proton, another is neutron, another is electron. So which one is the least heaviest particle here? The least heavy is one. This is 1840 times heavier than neutron and proton. So this is the least heavy. This is the lightest particle. So I am in the last week's lecture I posted, and I'm in slide number 11 there. And so this is the least heavy, and neutron is the heaviest, and this is in between here. So this is 1.004 somewhere. This is 1.006, something like this. So electron is the least heaviest. Proton is the most heaviest particle in the atom. Yeah, that is the mass. So now another example here in slide number 12. This is from the last week. So it is asking you, which is the following is the two. A boron has how many electron? All right. So boron 10. Boron 10 has how many electron? It is asking like that. So boron 10 meaning that like this. So if somebody writes like this, boron 10 means P. So this is a big number. If somebody like this, that's boron 10. That's a big number. Yeah. So they never write the small number here. So now you go to the periodic table and look. So I can go like hydrogen, helium, lithium, beryllium, boron. So which number? 1, 2, 3, 4, 5. Number 5 is the boron. Go to the periodic table and look. It's in the fifth box. The boron is there, right? So that number is here. This is the 5 is here. Yeah. So 5 is the number of electron. This gives you number of electron. Number of electron is 5. Number of proton is also 5. Number of electron and number of proton is always equal. Yeah. So how did I get this 5 here? I went to the periodic table and look which box is that, and that is the number of proton and number of electron. Make sense? Easy. Now, how many neutron are here? If you have to find out how many neutron are here, number of neutron. So this is 10. 10 is here. 10 minus 5. 10 minus 5 is 5. So bigger number minus smaller number gives the number of neutron. Make sense? So this kind of problem are in homework and in test. Yeah? This is one of the most useful information in the laboratory. They call mass spectrometry. So they call a lot of mass spectrometry in chemistry. In higher level in medicine, finding medicine, characterizing the material in hospital. So they use this kind of thing. So it's very important. Yeah. Good. So now let's talk another one here. So I am in the hydrogen isotope. So 13, slide number 13 from last week. So hydrogen is the simplest element. Hydrogen is 3 kinds. So this is hydrogen triplet. So if you go and collect the hydrogen in water, there are 3 kinds of hydrogen in water, yeah, or anything. So one is like this, 1, 1. Another is 1, 2. Another is 1, 3. So meaning that it has proton 1, electron 1. Proton 1, electron 1. So this gives you proton electron, and this is also proton 1, electron 1. So number of proton and number of electron are 1, 1, 1, 1, 1 in all kind of hydrogen. Make sense? But how many neutron here? Neutron. So how we get the number of neutron? This number minus this number, right? Or bigger number minus this smaller number, right? Number of neutron is 1 minus 1 is 0. So one kind of hydrogen there are no neutron, only proton and one electron. Yeah. So hydrogen is the simplest element in Earth that has no neutron. Yeah. And then so this is the mostly found hydrogen. So almost 99% or more is is found. So almost all hydrogen in water is this kind of hydrogen. And this is a little bit, we also find this kind of hydrogen, but in small amounts. So they call it deuterium. So number of neutron here is 2 minus 1 is 0. Sorry, 2 minus 1 is 1. Number of neutron here is 1. Yeah? And some of the hydrogen has 1 neutron. And here, some of the hydrogen has 3 minus 1 is 2. So most of the hydrogen in nature is this kind of hydrogen, 1 proton, 1 electron type hydrogen. A little bit small amount, it's a tiny bit. This is a very small amount. So this has this is a 1 proton, 1 electron, 1 neutron type hydrogen, and another hydrogen is, this is almost non-existent, very, very tiny. Yeah. So this kind. So this is the most abundant isotope of hydrogen in water. Yeah. Okay. Good. Now, so they have a different density. If you measure the density of water, so the density of water. So this is kind of water, so, right? Water. In water molecule, if this kind of hydrogen is there, the density of water is 0.917. So this is you measured in laboratory this way. So this one is that one. So if you have this kind of the hydrogen in water, this kind of hydrogen having water is density is 0.9998. So a little higher than this one, right? Because that's heavier. So it was 917 gram per cubic centimeter density. This kind of, if there is this kind of hydrogen in water, this has 0.998, so greater than that. So gram per cubic centimeter. So if you have the water of this kind, like again H2O, but in here there are 2 neutron in 1 proton system, and the density of this guy would be 1.11 gram per cubic centimeter. So this is the most heaviest water. Make sense? So if you mix 3 kind of water in a bottle, this is going to be at the bottom. This is going to be bottom. This kind of water, and a little bit higher density is this kind of water. So that will be here, and this water is the lowest density. So this kind of water will be up here. So we have 3 kind of water. Make sense? So this is the heavy, they call heavy water, heaviest water. So this we use in drinking. So this kind of water they use in nuclear reactor, where they make the bomb, atomic bomb, or nuclear energy production, something like this. Yeah. And also, if you study the chemistry in the future, they also use those kind of water in nuclear magnetic resonance spectroscopy. So they sell in tiny amount this kind of water and this kind of water. Good. So now I am in the last slide from the last week. So here is the percent abundance of isotopes. So percent abundance. So percent abundance means there are multiple kind of the isotope in of the same thing. So which is more or which is less? That is called the percent abundance. Yeah. So let's say here are in class there are 30 girls and 10 boys. So we have a 40 students here in our class. There are 30 girls and 10 boys. So what is the percentage abundance of girls and what is the percentage abundance of boys, right? So we just want to calculate the percentage. So percentage of girls would be 30 girls divided by total, 30 plus 10, 40 multiplied by 100. So this will give you, so kind of 300 by 4 would be 70%, approximately 70% are girls. So that's the percentage abundance of girls in this room. I mean, in our class, yeah? And then what is the percentage abundance of boys? So boys are about, we have 10 boys out of 40. So multiply by 100. That gives you 0, 0 cancel. So about 25% is boys. So let's say this is 25% and this is about 25%. So the percentage abundance of boys is 25% and the percentage abundance of girls is 75%. Make sense? So this is the percentage abundance. So this we did for the girls and boys in the class, but we want to do in case of the elements or the isotope of the carbon or isotope of the hydrogen, right? Make sense? It's easy. So don't think this is a chemistry, it's more like a mathematics, arithmetic. So percentage abundance. Now, here in slide number 14, I have a problem here. So here are the two kinds of the carbon. So one is carbon 12, another is carbon 13. So let's say this smaller are carbon 12 and this smaller are carbon 12 and this bigger are carbon 13. So two kinds of the material there, right? So both the same element, but some are heavy, some are less heavy, right? So what is the percentage of abundance of this carbon? So let's say I have here 1200 atoms. 1200 atoms. It's hard to drop 1200. So assume that there are 1200 atoms, right? Out of 1200 atoms, this is a 12. This is total. Out of 1200 atoms, 1185 is 1185. 1185 is carbon atoms are C12. C12. So these are C12 type. Make sense? So there are 1200 atoms. Out of this 1200 atoms, 1185 are C12 atoms, right? And I have about 15 atoms. So 15 atoms is 1515. So 15 atoms is carbon 13 type atom. So see that in nature, exactly this looks like in nature. So if you go in the nature and collect the 1200 atoms carbon, so 1185 has a 6 proton and 6 neutron. But out of those 1200, only 5 have 6 proton and 7 neutron. Make sense? So this kind. So what is the percentage abundance of carbon 12 and carbon 13? So percent abundance of carbon 12 is, so percent abundance of percentage of carbon 12 is, so how many carbon 12 are there? 1185. 1185 out of how many? 1200. Multiply by 100. So how much it gives you is 98.75% of C12. So C12 abundance is 98.75. Yeah? Easy. Just like the boys and girls calculation out of total. Now, how much is the C13 now? C13. Percentage of C13 is, percentage of C13 is just 15 atom out of 1200. So 15 atom out of 1200, and then you multiply by 100%. So that gives you 1.25%. So 1.5% is C13 type atom, and in the nature, and this 98.75% is the C12 type atom in the nature. Yeah? Easy? So whatever is number divided by the total number, multiply by the 100. Yeah? That gives you the percentage. Looks simple, but this concept is really important in future in doing the mass spectrometry. Yeah. Good. So the percentage abundance, I'm done from the last class. So I start the new thing here. Now there are a couple of problems here. So I just wanted to practice with you. This is from the today's lecture. Yeah. So in today's lecture, in the first slide, so this is review and check for section 2.2. So it's in the book page 48. Yeah. This is an example in book page 48. Yeah. So I'm going to practice that one. So the mass of an atom of manganese is 54.9380 atomic unit. How many neutrons are contained in it? So, it's asking for the manganese, right? So manganese. So expect something like this in exam. So this is a manganese. Manganese is Mn. Yeah. So you will see something like this in exam. So this is a manganese Mn. So now it gives the mass. So the mass of an atom, it is giving the mass, right? So mass meaning that proton plus the neutron. It's not mass means not the proton. Proton plus the neutron. So it says 54.9. So I told you just round it. 54.9 is about 55, right? So it's just round it. So it says it gives in the problem it gives you 54 mass is 9380 atomic mass unit. So just round it. 54.9 is 55. So write that big number 55 here. Make sense? So you just round it. Now look the periodic table. So there is a periodic table, another periodic table I put in the today's lecture, but you can use the same periodic table that I posted in last week's lecture. So manganese. So look the manganese. So manganese is in number 25, 25th box. Just keep counting, and there is clearly written 25. The small number is 25. So write the 25 here. So small number is 25 and the 55 is given, right? Where did I get this 25? I just looked the box and there is a small number is 25, right? Make sense? Good. So now, so this is proton and electron. So number of proton and number of electron is 25. How many number of neutron? So this is proton plus neutron. So proton plus is 55, proton is 25. So neutron is bigger number minus that smaller number. So 5, 5, 0, 30. So this is 30 Newton here. Make sense? Simple, but important. Yeah, it's simple but important. Now, let's look the question number 2 in the same slide. An atom contains 12 neutron and has mass number of 23. So, number 2, it says, in number 2, it says, an atom contains, so this is the atom, so I just write the X. I don't know what that atom is, right? So I just put X at this moment. And it says 12 neutrons. So 12 neutrons are 12. Then how many has mass number 23? So mass number, you can write the mass number. So mass number is 23. So this is a bigger number, this is another number. So subtract from this to this. So mass number basically is number is proton plus the neutron, right? The mass number is always proton and neutron, right? So mass number is given, so that is 23. Proton is not given, so neutron is given. So proton I don't know, neutron is 12. So like this, yeah. So how many is the proton there? So proton is 23 minus 12 is equals to proton. So I take this 12 this way and subtract it. So the proton is equals to 11, right? Number of proton is 11. Make sense? So from the big number, the mass number is a big number. Neutron is another smaller number, so I subtracted from big number to smaller number. So when I subtracted from big to small, what is not given, that way it can count. So neutron is given, proton is that one. So proton is 11. Now go and look the number 11 box. Yeah. So the 11th box in periodic table is number 11 is sodium. So you go to the periodic table and look where there is a 11. Yeah. So 11 is sodium. That is sodium. Number. So from this proton, we need to find which element is that. Proton is proton 11. Where is there proton 11? So number 11 box is the sodium. So this is 11. So this is 20. Make sense? So this is the mass number proton and neutron. This is the proton. So proton is the identity of the material, whether it is carbon, whether it is sodium, whether it is potassium. Easy. So just subtract it and what is there? Now let's go to the slide number 2 in today's slide, and then we just practice like this question. So I already solved this problem there, so you can read it home. So the question 1 here is silver has 2 isotopes, one with 60 neutron and the other is 62 neutron. So silver is Az. So look the periodic table, silver. So there are 2 kinds of the silver, like the duplet, right? Twins. So silver. So this guy has 60 neutron and this guy has a 62 neutron. It's not a mass number. I have not added the proton here. I'm just writing the neutron. Yeah. Here we should write the neutron plus the proton. Neutron plus the proton. Yeah. This is just the neutron. The problem is saying that this is just the neutron, and I have not written proton here. So look the silver. Where is the silver? So look the periodic table, and the silver I can see Az. Az is a silver, so it's a 47. So you look there. Copper is just below copper. Copper is 29. Below copper there is silver, and then silver is 47. So in the 47th box is the silver. Yeah. So look there and write that. So that 47 small number is 47. So what is this one? Number of proton. So number of proton, number of electron. This 47. That's atomic number. This is also number of proton, number of electrons. Same material, silver, but they have different neutrons. So neutron is 60 here. Now how many proton here? 47. So just add that there. And how many proton here? 47. Same. Make sense? So I'm just adding the number of proton and neutron together. Just you need to go to the periodic table and should find the AZ. And what is the atomic number? 47. Right 47? Right 47. But the problem is saying one kind of silver has 60 Newton, another kind of silver has 62 Newton. Now I'm going to add the proton here. So this is neutron, this is proton, this is neutron, this is proton. From here what I get is silver. This is 47. If you add this and this number, you will get how much you get? 107. 107. If you add this and this number, how much you get? AZ, that's a 47 proton electron, and neutron plus proton is 109, I guess. This is 109. So two kind of silver are there. Okay? You need to use the periodic table to find that 47. Make sense? Good. You need to do a couple of times practice. So it is giving me that one kind of isotope that has 60 Newton has how many? 51.839%. So if you go to the nature and collect some silver atom and start to count. So if you get 100 silver atom, out of 100 silver atom, 51.839 atoms will be this kind of silver out of 100, right? So this is saying that. So how many atoms will there be like this? So 100 minus, because you have 100 atoms, out of 100 atoms, you have this kind of silver, 100 minus that number is this kind of silver. So that is 51.839. So this gives you 48.161%. So if you go to the nether and collect the carbon atoms, silver atom, approximately 52%, 58.1.8 means almost 52% are this kind of silver atom. Say 47 proton and 107 proton plus Newton type of atom, and approximately 48% is silver atom has 47 proton and 47 Newton and proton. Make sense? Like this, percentage. Yeah, just like the boys and girls calculation. Good. Now, yeah, here is another problem in this. This is from the book page 50. So this one is it's saying the same thing. So there are three types of the argon. So they go to the nature and start to collect the argon atom. So argon, one type of argon, another type of argon, another type of argon. So if we go and collect the argon atom in the nature, there are three types of argon atom we can find, right? So they say out of the I don't know how many. So they collected some argon atom and they counted and they found that like this. So this was 36. So this is proton and neutron 36, proton neutron 36 type of argon atoms were 504 atoms. They counted and they got 504 atoms. So they collected some carbon atom and they started to count how many this kind of atoms are there. There were 504 atoms, this kind. And this kind was 38 argon. So 38. So proton plus neutron were 38, and this kind of argon atom there were, they counted and they found how many? I think this is 508. This is a 2690. Sorry, this one is a 2696 atom they found. This kind of atom they found was 504 atoms, and this kind of where there were 40. There were 40, means that proton and neutron were 40. That kind of they found 7.968 10 to the power 5 atoms. So they collected the argon in the nature and bring in the laboratory, and they counted, and they found that out of all this in the box, out of all this box carbon atom, they found, sorry, argon atom, they found 2696 2696 were this kind of argon, 504 atoms were 38 type of argon, and a lot. So this is 796,800. If you multiply 10 to the power 5 this one, you get this number. So that many argon 40. So this is the most abundant isotope in the nature. Yeah. So a lot of this, but this one is small amount. Small amount. This is almost non-existent. Very, very small amount, right? And now I need to find what is the percentage abundance. Yeah. So percentage abundance means sum all. So total is how many atoms there? Total atoms. Number of total. Total number of atoms is 2696 plus 504 plus this one 796,800. 769,800. So this is the total number of atom in that box I have, right? So that gives you a number 8. So if you sum this, that gives you 8. 1, 2, 3, 4, 5. I think 8 followed by 50. So if I add this one, so I got this one. Now I need to just calculate the percentage. What is the percentage of this guy? So that many atom out of that, right? So that is 8. 1, 2, 3, 4, 5 multiply by 100%, and you divide by this total 1, 2, 3, 4, 5 multiply by 100%. So and this one is this divide by 1, 2, 3, 4, 5 multiply by 100%. So whatever the number comes here, just put it here. So the first one is so get whatever the number comes. So this number gives you the argon 36 type percentage abundance. The number here gives you argon 38 type of percent abundance, and this will give you argon 40 type of percent abundance. Make sense? This is percentage calculation. So first we add it all and just calculate the individual percentage, right? Make sense? So you can just look those, and I already did it here. So argon 40 comes to be 99.60. So this number comes to be 99.60%. So this is the most abundant isotope in the nature. So if you collect 100 atoms of argon in the nature, almost all will be 99.6. Almost 100% will be this one. This one and this one is very, very small amount. Yeah. Make sense? So now. How to get the atomic weight? Now, so in another slide number 4, I have atomic weight. So it's just like the average weight. So atomic weight is the average weight. So let's say there are 10 students. There are 10 students. And out of 10 students, 6 students have let's say 70 kg. 6 students has 70 kg mass. 70 kg mass, right? Out of there are 10 students, 6 students has per student has 70 kg mass. So approximately our mass is 70, 60, right? So 70 kg mass. And another 4 students has let's say 60 kg mass. So what is the average mass of the all students? So that's called the atomic weight. Make sense? So we have students. There are 2 types of students. One type of student are 70 kg mass type. Other kind of student are 60 kg type of student, right? Now what is the average mass of the each student? Like kind of average. So we would do something like this. So we do 60 multiplied by 70. So that will give you that 60 multiplied by 70. So that will be the total mass of this student. plus 4 multiplied by 60 will give the total mass of this student, and then this plus this will give the total mass of all students, right? And then to find the average, I will divide by total would be 10. So that gives you the kind of the average. So that would be 420. That would be 2 plus 240. So divided by 10. And if you find the average, so how much is the average? So that's 6. That's 4. That's 4. This is 0. And then did I do something mistake here? So maybe I did something mistake. This should not be the mistake, but 6, 4. That's 4. That's good. So 240, 420. So that gives you, I think I did mistake here. So that is 600. So 660, right? Divide by 10. So if I divide this, I get the 66 kg. So the average mass of the student is 66 kg in the room, right? Make sense? So this kind of is called the atomic weight. So we need to calculate the average mass of one kind of atom. One kind of atom, like the C12 they give, and the C13 they give, and then we just get the average of C12 and C13 and put it there, and that is the atomic weight. Make sense? Just like how I did it here. So there were 10 students, and each of these 6 students were 670 kg. Out of 10, the 4 students were 60 kg, and then so that this is the mass of 6 students, 600, and this is the mass of these 4 students, and then I added those all mass, and I divided by the total number, and I get the mass of average students. So this is kind of the atomic weight, average weight of what we find in the yeah. So I'm going to do some atomic weight and see how it will do. So, atomic weight is calculated as percentage of one isotope, given isotope. Let's say percentage of isotope A, isotope 1 or isotope A, isotope 1, and you need to remove the percentage. To remove the percentage, you write the 100 here. To remove that percentage, we need to write the 100 there, yeah? And then multiply by the mass of this isotope. Plus percentage of another isotope, isotope 2, and then to remove this percentage, you need to put 100 here, and then the mass of that isotope. So this gives you the atomic weight. Yeah, when the percentage is given, you have to calculate like this. Previously, percentage was not given when I was doing the boys and girls calculation, right? So I just multiply number of boys and mass of each boy, and number of girls and mass of each girl, and I sum, and then I divided by all the students. But if the percentage is given, we do the sum, but we have to remove this percentage. So this is the formula. So this kind of the formula in the periodic table, you can look everything in the exam. Yeah, you just need to know how to use the formula. So formula and the periodic table you can use in exam. Yeah. So in an exam we can use it. So let's do one here. So I have 10-minute time. So boron has it is giving me boron has 2 isotopes. So we have a boron. Boron has 2 isotopes. One is B10, another one is B11. So B11. So the 10 meaning that it has this 10 means it has a number of, this is the number of proton and number of neutron. Yeah, atomic mass number. This is the mass number. So if you have to write another way, this B10 will be written as like this B5. So if you look at boron is in number 5 in periodic table. So B5 and this is 10 like this. So if you like, you can write like this way, or you could write like this way, B5 11. So like either you can write this way or this way, or either this way or this way. Yeah. So there are 10 neutron plus proton. So this is also 11 neutron plus proton. Yeah. Make sense? So now it is giving me what is the percentage of this B10 type material. So B10 type material is 19.91%, and this B11 type atoms are 80.09%. So go to the nature and collect the boron atom. So probably you can find the boron atom. You buy a bottle of the boron atom, the boron, and then you start to count the material. So if you take the 100 boron atom, 99 and approximately 20 atoms are B10 type, and approximately 80 atoms are B11 type. That's what it is saying, right? So what is the atomic weight of this one? Now we need to find the average atomic weight. So if there were only this type, atomic weight would be B10, right? If only this type, the atomic weight would be 11, right? But now some are this type, some are this type. So what is the average of this this two number? That's what we are trying to find, right? So apply that formula. So atomic weight is equals to this formula, the percentage of isotope 1. So isotope 1 is 19.91, right? Percentage of isotope 1 is 19.91. So I'm putting there 19.91. That's a percentage, and I put 100 down here, 100, and then I multiply by its mass. So its mass is 10, right? Make sense? It's a 10. So the mass is given. It's more accurately, the mass is given as 10.0129. I could just put a 10 also, but since it is giving a very accurate mass there, the mass of this guy is, they are finding very accurate. So the mass of this one is given. Now plus, now this is this plus here. Now percentage of another isotope. So percentage of another isotope is 80.09. 80.09, and then I have to write 100 here, and mass of this isotope, the mass of this isotope. So the mass of this isotope is 11. The mass is 11, right? I could just use 11, but they are giving the more accurate mass. So the more accurate mass they are giving is 11.0093, right? But if it is not given, I can write just 10 and 11, yeah? 11.003. So multiply by 11.003. So just put this number in calculator, and you will get 10.811 atomic mass unit. Make sense? Simple. So the 19.91, its percentage, and this number is its mass. So that's approximately 10.0129, and this number 80.09 is its percentage, and this one is its own mass. So that is approximately 11 point something is given here. 11.000090 0090. I think 0090 is given. So just put in calculator, and you get this number, and this is the average atomic weight of the boron. Make sense? So you'll see one problem in homework. I will put one lithium example is there. So you will do like this. Yeah, good. So there will be in exam also. So this is the average of all kind of the isotope. It is the atomic weight. Yeah, good. So this 100 and this 100 is just to remove this percentage here. Good. So I'm done here. So we still have 5-minute time. So all problems like this. So in another slide number 5 is exactly like this one. You can practice yourself in home. So 5 and 6, exactly same thing. So slide number 5 and slide number 6, exactly what I did here. They are the exactly same thing I take from the book. So you practice yourself, yeah. So now what else here? I think that's it. Now I'm going to do slide number 8. So the slide number 8, I'm in slide number 8 now. This is a little complicated, but I don't put this in the exam, yeah? So this is just for the practice. So some people, I think we have some students are very, very good background in chemistry, and some have really not taken the chemistry in high school. So this kind of problem, this the slide number 8 problem, I don't put in exam, but I just practice in class, yeah? So maybe Okay, so let's, I introduce the problem and then we do next class. So in slide number 8, it is giving a problem. So the problem says, I have a SD atom, SD. So it is an antimony. So antimony. So one antimony is a 121 type, 121 type, meaning that protein in neutron are 121 there. Another one is antimony that is 123 type, 123 type. And the mass is, its mass is approximately 123, which is 122.904 atomic mass unit. And this, the mass of this one is approximately 120.904 atomic unit. So this 121 is close to 120.9 is close to 121, right? So this is the mass, this is the mass. But this is not giving me the percentage. What is the percentage of this in nature? What is the percentage of this in nature? So I need to find out. So percentage is not given. If the percentage is given, it is much easier. But if no percentage is not given for both, it is a little bit harder to solve. And I will teach how to do that in next class. Yeah. So previous was easy. So you have a mass, you have a percentage. Percentage multiplied by mass by divided by 100 plus another isotope percentage multiplied by mass divided by 100 and put those in calculator, you get the atomic weight, right? So that's much easier. In those kind of problem you will see in homework and the exam. But this one, so there are two isotopes of this guy, antimony. One is 121 types. That is, mass of this guy is 121, and mass of this guy is 123. So you collected some antimony atom from the nature, and how much percentage it will be there, and how much percentage it will be there. So how to find that one? Yeah. So this is kind of the back. So this kind of problem you really don't have to understand, but since there is one in book, so I just teach how to do that. Yeah. In next class. So I already solved it here. So if you have time in home, you can look it, but I will teach in next class. Make sense? Good. So I think we stop today. Thank you very much, everyone. What topics does the first assignment cover? The one that due in Friday. So that's the chapter 1. Only chapter 1. Chapter 1. So the homework I put there is once you understand this lecture and go through the lecture notes, and if you understood these lecture notes, you can easily do the homework. Yeah. But if you cannot do, you can go back and look the other material. But I think that once you read these lecture notes, then you will be able to do it. Everyone, thank you. Thank you, everyone. All right.